Okay, today we're going to take a look at some different types of long division. The first we can see here is dividing by place value models. We have the number 243 divided by 8. So essentially what we have to do is to make 8 equal groups from everything we see. We have two 100s, which obviously we can't put two 100s into 8 equal groups. So we have to trade in the hundreds for 10 tens. So I have these pre-made underneath. And then we'll trade in this 100 also for 10 more tens. At that point, we have 10 tens for the first 100, 10 tens for the second 100, and 4 tens for the 43 we started with. Still have 243, but now we can put those into our 8 equal groups. And if I just draw 1, 2, 3, 4, 5, 6, 7, 8 equal groups, and we can start putting our tens in there. So this one's going to go up here. This one goes here. This one goes here. This one goes here. All those tens are now gone. We should do the same thing with the 20 we have left over. So this one can come over here. This one can come here. This one here. This one here. Every group now has 1 10, but I still have a whole lot of tens left, so I can start the process over again. 1, 1, 1, 1. 1. And then I come down here, 1, 1. So at that point I have to decide, do I have enough tens left to fill up every other group? I have 8 groups, I have 1, 2, 3, 4, 5, 6, 7, 8 tens left. Yes, we can have 1 10 to each of our groups. And now you can see we have 30 in each of the things. We still have our 3 1s left. Well, can I take 3 1s and put 1 1 in each group? No. So we end up with a remainder of 3. In all, our answer here, we couldn't do any 100s, so 0 hundreds. We ended up with 3 10s in every group. We ended up with 0 1s in every group, and we had 3 left over. So that's a very good conceptual understanding for kids. They understand breaking the hundreds down into tens, how many go in each group, and what's left over. A second method is the box division you hear about. Well, box is basically exactly the same thing. This 2 here represents hundreds. This represents tens, and this represents ones. So just like doing a standard algorithm, we would say how many 8s go into 2. And we all know that 0, just like the previous model, we can't do it. We subtract it. There's 2 left over. That 0 is the number of times it went in. Then we come over here, and we have 2 left over, so 2 gets brought over in front of the 4 10s. Now we have our 24 10s, just like the previous model. So we say, okay, how many 8s go into 24? We know that's 3. 3 times 8 is 24. We subtract again, 0 left over. A good idea is to go ahead and bring that 0 up in front of the 1 so we can keep that process going. And we say again, how many 8s go into 3? And it's 0 again. 0 times 8 is 0. We have a remainder of 30, which goes up here. 30, remainder 3. Same type of thing as the algorithm, same type of thing as the place value model. We're getting the same answer, just coming about it different ways. The third method, I personally call partial division or partial subtraction. We're saying we have this nice long line out the side, and I'm going to say, okay, how many 8s do I know go into 243? And I can pick any number. I can pick 10. If I put a 10 here, That means 10 times 8 is 80. And we'd have to subtract that. 3 minus 0 is 3. Can't take 8 from 4, have to regroup it, or decompose it. 14 minus 8 is 6, and I have 163 left. Then I could say, okay, well, I can take 10 more out. So I take 80 away again. 3 minus 0 is 3. 16 minus 8 is 8. Hey, look, I can do it one more time. Another 10 comes out, and I'm left with a remainder of 3. I can't take any more 8s out of that, so it's a 3 remainder. So what I do is I do how many 8s I take out? 10 plus 10 plus 10 for a total of 38s and a remainder of 3. On the second note, we could do the same problem, but a totally different way. Some kids might say, well, I can take 20 8s out. And they know that 2 times 8 is 16, so 2 times 8 times 20 is 160. They can subtract 160 from it. 3, decompose that. We have 83 left over. They're probably going to see 10 more. And again, 20 plus 10 is 30. And again, I have a remainder of 3. So many, many different ways of getting the answer there as long as they multiply correctly. All ways for kids to conceptually understand how to divide larger numbers.